A ball is projected vertically up from the tower of I 20 meter. Okay, here is telling the ball experiences a constant A drag of 2 meters per second during its motion. Find the time of flight and the speed with which it strikes the ground. Okay, let this be the point 1. The ball initially is projected at t equals 0 here. It will reach, then it will come and strike the ground. So during its path, we'll analyze it. What is the motion of it? A drag, so the G will act here down. The A also will act down. Here it will be G, this is A. I think previous one problem we have done. So the resultant acceleration here will be A2, it will be A1. So what is A1? G plus A, 10 plus 2, 12 meter per second squared. What is A2? G minus A, 10 minus 2, 8 meter per second squared. Okay, it will ascend certain height. H, we'll take this. First, we'll calculate that H. H is equal to U square by 2A1. U is how much? 6 meter, 6 square, 2 into 12. 36 by 2 into 12. 3 by 2 meter. It will ascend to a height of 3 by 2 meter. Then from there, it is going to fall freely, and this will be instantaneous rest. Okay, let me take times in this way. So what is the time of ascent? Equal to U by A1. So U is how much? 6, A1 is 12, 0.5 seconds. So the ball will take 0.5 seconds to move to ascend to height h. Then from there, it's going to fall freely. What height it will fall freely? Small h plus capital H. H is equal to A2 T23 square by 2. Small h plus capital H. This will be 3 by 2 plus 20. A2 is equal to 8 by 2. T23, we don't know this, has to be calculated. So 240, 40 by 3. 40 by 3 equal to 8 by 2. 80 by, okay, this will be 4, 5, 10, 10 by 3, root 10 by 3 seconds. So what is the total time of flight? Total time of flight is equal to T equal to T12 plus T23. T12 is 0.5, 10 by root 3. 3.3, 3.33 it will come. Let me check with calculator. .33, 1.82, plus 0.5, 2.32. This will be time of flight. With what speed it will strike here? So with what speed it will strike means Vg is equal to, we can write it as 2A2h. It will fall freely from a height small h plus capital H. 2, so the value of A2 is, we have here 8. Small h plus capital H. Small h, where, okay, 3/2 plus 20. 43, 18 to 43. 344. It's under root of it. 18.54. So finally, the ball will come and strike the ground with this much of speed. Speed of ball when striking the ground. Okay, now some good analysis we are supposed to do here. Look at the retardation and look at the acceleration. It is less, no? So can we compare the VT graphs for it when it is falling freely, when it is not falling freely, when with a resistance, without a resistance? I just want that corresponding graph, how it will be. So first, this one will be with a resistance, without a resistance. Now with a resistance, the retardation is more, no? Therefore, the curve will come in this way. Then afterwards, the free fall will be somewhere here. These curves are very important. I'm projecting with a speed u. I'm projecting with a speed u. Velocity, we are plotting it. And this is t in seconds. So what is this curve? This particular curve is without a resistance. And what about this? With a resistance. Then what about the other curves? Position versus time. So the first, it will retard. Take this. First, it will retard. Comes to instantaneous rest. Then it will be in this direction. So this will be h minus h. These two curves should not have same slope. Oh. Not equal to theta1, not equal to theta2. This is very, very essential. This is the total time of flight. Okay, we had the discussion about all the different bodies. That one. Let me. Okay, kids, we had the discussion of the different types of the numericals for the motion